Here we are asked several questions about two compounds. We are told the two compounds, which we have called compounds 1 and 2, belong to different homologous series and both have the same molecular formula, C4H8O2. First, we need to give a definition of homologous series. This is a family of organic compounds with the same functional group and same general formula, but where each member in the group differs from the next by a CH2 unit. Next, we need to identify two homologous series that these compounds could belong to. Well, the molecular formula for each, which is the same, has this general formula, CnH2nO2. Carboxylic acids and esters both have this same general formula. Next, we are given the vapor pressure of each compound. Vapor pressure is the pressure exerted by a gas which is in equilibrium with its liquid in a closed system at a fixed temperature. We need to identify the structural formula of the first compound from its vapor pressure. We know one of the compounds is a carboxylic acid and the other is an ester. Compound 1 has a low vapor pressure, and this means that lots of energy is required to overcome the forces of attraction between the molecules. So the forces between molecules of compound 1 must be strong. Compound 2 has a high vapor pressure, which means that little energy is required to overcome the forces of attraction between molecules. So the intermolecular forces are weak. We can say that vapor pressure depends on the strength of the intermolecular forces of attraction. Now, this is the general structure of carboxylic acids, and this is the general structure of esters. In the carboxylic acid, a highly electronegative oxygen atom is bonded directly to a hydrogen atom, and this results in the electron density being pulled more towards the oxygen, forming a delta negative oxygen and a delta positive hydrogen. This results in hydrogen bonds between the delta negative oxygen atom on one molecule and the delta positive hydrogen atom on a nearby molecule. Hydrogen bonds are strong. But in esters, the charge distribution is across the carbonyl group. The delta positive carbon on one molecule is attracted to the delta negative oxygen on an adjacent molecule. This is a dipole-dipole interaction. Dipole-dipole interactions are weaker than hydrogen bonds. Now that we know the relative strengths of the intermolecular forces, we can identify that compound 1 with a stronger intermolecular force must have hydrogen bonds, and so must be the carboxylic acid. And compound 2 with the weaker intermolecular force, which must be dipole-dipole forces, must be the ester. So the structural formula of compound 1 is the structure of the carboxylic acid, and we know it has 4 carbon atoms, so it must be butanoic acid. Then we must give the name of the second compound. We know it is an ester with 4 carbon atoms, and there are a few possible options. Methyl propanoate, or ethyl ethanoate, or propyl methanoate. The first part of the name ending in -yl refers to the substituent bonded to the ester oxygen, which does not contain a carbonyl group, and the second part of the name refers to the portion of the molecule which contains a carbonyl group.